today's class. We know that in this platform, we have promised you that we'll be giving you all the best in chemistry. We make chemistry as simple as possible, bringing you topics that we perceive that are problematic in the classrooms, and we try to solve them. And for you not to miss out, I will just remind you to please subscribe. When you subscribe to the channel, whenever lessons comes up, it will pop up and you'll be able to have it first hand. Today we want to go to the gas law, and in the gas law we'll be treating the Lussac law. We discovered that among all the gas laws, the Lussac law tend to be problematic, even though it is the simplest. So today we will go to the Lussac law, but firstly I want to define the Lussac law for you. You know that I may not define it verbatim, but just to explain it, the Lussac law states that the elements or gases combine in simple whole number ratio. When gases combine, they do so in simple whole number ratio one to another. Let's take, for example, we have gas A combining with gas B and to form AB. If you look at gas A, we have 2 volumes of gas A and we have 1 volume of gas B to produce 2 volumes. That means this combined in ratio 2 to 1. So now, if they are combined, one thing you must ensure that for there to be a product during the explosion or combination, one of the gases will be completely used. One of the gases will be completely used. That's where students will have problem. You have to identify which of the gases will be completely used and which one will have remnant for you to have a product. And that is exactly what I will deal with today. And that is why the Lussac law is also called law of combining power. So now you can see that in this volume now, for there to be this volume, we must know that there will be 2 ratios. That's exactly what comes to water. When you have 2 hydrogen coming to oxygen to give you H2O, you balance the equation, you put this here and you put this here. That's to tell you that for there to be in water, there must be 2 volumes of hydrogen and there must be 1 volume of oxygen. Now let's see an example how WAEC or NECO, even JAM, do ask questions. Let's see this question here. It said 20 cm³ of carbon monoxide were exploded with 30 cm³ of oxygen over a solution of potassium hydroxide. Calculate the volume of the resulting gas after it has stood for some minutes. Some students will have problem with this potassium hydroxide. Just ignore the potassium hydroxide. Look at the gases that exploded and write an equation for it. Say carbon monoxide. This is carbon monoxide exploded with what? With oxygen. And whenever carbon monoxide explodes with oxygen, we know it will give you carbon dioxide. Now this is balance the equation. This is 2 volumes of oxygen. Now here we're having 2 volumes of oxygen. Now we're having 3. What you do is to balance the equation. If you put 2 here, then you have to put 2 here. So that we have 2 carbon, and mind you, these are gases. Even though these are insignificant, but for you to understand. Are we together? Alright, now this is 2 ratio 1, and it gives you 2 here. These are the things you must know. Now this is 2 volumes of carbon monoxide, 1 volume of this. Now go to the question. He said before the explosion or before the sparking, there are what? 20 cm³ of this, and we have what? 30 cm³ of this. As I said earlier, yours is to identify which of the gas will be completely used. If you look at this now, if I'm to use all of 30, that means I need 60 cm³ here, and it was not provided. Because if ratio 1 is 30, ratio 2 to that will be 1 to 2 of 30 will be 60. But from the question it was not provided, then I will know in my mind that I will not use all of 30. What I will use is all of 20. Because when I take 20, then half of 20, which is ratio 1, will be 10. So that with that factor in mind, you solve the problem. So after explosion, what will happen? If all of 20 is done, and ratio 2 to 1 of 20 will be what? 10. Very simple. 2 is ratio 1 of 2. Ratio 2 to 1 of 20 is what? 10. That means if you have 20 volume of this, 1 of it will be what? 10. Then that will make this one 2. 2 ratio of it will also be what? 20 cm³. So the question now says, calculate the volume of the resulting gas after it has stood for some time. So the volume of the resulting gas is what? 20, just like that. The volume of the resulting gas equals to what? 20 cm cube. Mind you, the questioner can ask you, what is the residual gas? What is the residual gas? Residual gas means the gas that is remaining after explosion. Here we have 30, and out of 30 we have used what? 10 from it. So the residual gas will be what? 30 minus 10, and that will give you 20. Residual gas, in case they ask for residual gas. Alright? The questioner can also ask you, what is the total gas, or what is total residual gas? Total residual gas, it means the residual gas, that means the remaining gas and the gas formed. So total residual gas, if you talk of total residual gas now, total residual gas, that will be gas remaining plus gas resulting, that means resulting gas. So what is gas remaining? We say that will be 30 minus, which is 20, that will be 20 plus gas resulting gas, which is 20. So the total resulting gas will be 40 cm cube. It's as simple as that. So check for more questions, practice more, so that you'll be able to master it. But should you have any problem, just put it in the comment section. I'll be able to answer your question. So thanks for viewing. I want to say again, press that subscription button for more updates. Thank you.